And welcome back, and it is the 29th of February, the higher plus 5 a day, and let's just jump in with this first question. Okay, so what do we have? So radius of a sphere, radius of a cone, volume of a sphere, volume of a cone. This is one of those questions whereby you get marks for just doing something correct. So I would argue to you the fact it talks about the volume of a sphere and the volume of a cone, at the very least, let's just work these things out, because that will get us some marks. Obviously, do the whole question, but this will get us some way there, won't it? So the volume of a sphere may well be on your formula sheet, or it may tell you within the exam, but either way, it's good to know these things straight off. So they're going to be 4/3 pi r cubed, where I know the radius is 4. So it's going to be 4/3 pi times 4 cubed, which is going to be 256 over 3 pi. And 4 to the power 4 is just one of the things I kind of know, because 16 squared is 256. So not too bad to start. And again, definitely a mark in the exam for starting to set it up. Next part, volume of a cone. Again, maybe on your formula sheets, may not, but either way, it's worthwhile making sure you know them anyway, just so you don't have to mess around trying to find them out. So volume of a cone is 1/3 pi r squared, which again is 4 squared, because it tells you the radius of the cone is 4. And then I'm multiplying that by the h that I don't know. So my height of my cone, I'm going to say is h. And let's tidy this up. So that's going to be 16 over 3 pi times h. And then the question says the volume of the sphere is twice the volume of the cone. So therefore it must be the case that, I'm going to write this nice and big, because I think I'm going to do a lot of cancelling here. So 256 times pi is equal to 2 times, again, let's write this carefully, times 16 over 3 times pi times h. And I'm leaving a few gaps because you're going to see me do some cancelling here, and I want to do this really clearly so you can see what I'm doing. I would know easily straight away the pi's cancel. That's good. I would also notice the 3's cancel because I'm dividing by 3 on both sides. So that gets rid of that. The bit that's a bit trickier or a bit easier to get wrong. So do this very carefully if you're cancelling down, because errors are made here. The 256 and the 16 cancel down to 16 and 1. So let's think about what we've got left behind. So I'm left behind with the 16, the pi is cancelled, the 3 is cancelled, the 256 is cancelled down. The 2 is still there, and everything except for the h is remaining. So actually this is not too bad at all, is it? H is equal to 8 centimetres, because I know I'm working in centimetres. Looks worse than it is, but sort of nice. This could be a non-calculator, but a nice question either way. Next question. On Friday, 30% of people visiting leisure centre swimming, 90% of people swam were members, 80%. If you haven't already, read this question through again. This is one of these questions whereby the setup matters. So I'm going to think about the two things that are happening. So the two things that are happening are if they're swimming or if they're a member. So I'm going to think about my breakdown of those that swam. So these are my swimmers. So either they swam or they didn't, or they're a member and they're either a member or they are not. I'm going to think of it a bit like a tree diagram, but it's actually a frequency diagram. And they're either going to swim or they're going to not swim. So I've used a set language, a complement language. And then they're either going to be a member who swims, or a member who doesn't swim, or not a member who swims, I should say, or a member who doesn't swim, or not a member who doesn't swim. And let's think about what percentages I've got. So on Friday, 30% of the people visiting a leisure centre went swimming. So therefore I know this number here is 30%, which I know this number here must therefore be 70%. So far so good. 90% of the people who swam, so of those that swam, 90% of them were members. So I'm going to write down 90% here, which means that's 10%. And then it says 18% of the people who visited the leisure centre but did not go swimming, so these are the 70% that didn't go swimming, were not members. So in other words, this is 18% here. So 18% who did not swim were not members, so not and not is 18, which means this one here is going to be 82%. So you can see my individual trees add up to 100%, but I can't add up going all the way down. I'm thinking about it tree by tree. Then what does it want me to do? So it says find out what percentage of the visitors to the leisure centre were members. So members are going to be these people here plus these people here, i.e. swimmers are members and non-swimmers who are members, which is going to be 0.3 times 0.9, which is 0. Let's move over here, which is 0.27, or 0.7 times 0.82. Which is going to be, well, I can't pretend I know what that is, so let's put my calculator, so 0.7 times 0.82, which is going to be 0.574. And then if I add these numbers together, so add this number with this number, these are all the people that are members. So 0.27 plus 0.574, that gives me 84.4%. And that is, let's write it here so you can read it, 84.4%. Again, really nice question, really difficult unless you get the layout and think about how to break this question down carefully, but not too bad. Definitely much better once you've done one all by yourself. Next question. Okay, so the next question says calculate the size of angle DCE. So the first step is to identify which angle you need. So I need this angle here. So this looks a little bit like a sine rule question, doesn't it? So I've got my opposite and I've got, well, I don't have an opposite here, but I do have this angle here. So there's a couple of things I could do. I mean, I could use a cosine rule. In fact, actually, that is what I'm going to do. I'm going to use a cosine rule to work out CE, and then I'm going to use a sine rule to find out the angle I'm looking for. The other way I could do it is I could do the sine rule twice, but I'll do the other way around. So what have I got? I'm trying to find CE. Now again, I'm going to do this in one go. You've seen me do these things before, so let's talk through it. So CE is going to be the other side squared and added together. So 9 squared plus 20 squared minus 2 times 9 times 20 times cos of the angle in between, which is 50. I'm going to get my calculator out and I'm very carefully going to work that out because obviously that's key to what I'm doing. So that's going to be 9 squared plus 20 squared minus 2 times 9 times 20 times cos 50, which is equal to 15.798 or 15.799. So 15.799. Now at least a few extra decimal places because I'm going to use that number now. So now using the sine rule, what am I trying to do? I'm trying to do an angle, so put the angle on the top. So therefore sine of the angle I need, I'm going to call this theta. So in other words, this angle here is theta. So sine of the angle I need divided by the opposite side is equal to sine of the angle that I know divided by the opposite side, which I've just worked out to be 15.799, which means that theta is equal to sine minus 1 of, now let's do this carefully, so it's going to be 20 sine 50 divided by 15.799. Again, calculator out, and that is going to be 75.9 degrees. Now, this is where we have a problem. Because I've used a sine rule, I actually don't know if it's 75.9 degrees or 180 minus that, which is going to be 180 minus my answer, which is going to be 104.1 degrees. So I don't know which of these is true. So I'm going to have to think of something clever now to try and work out which one, because the diagram normally makes it a bit more obvious. Now I would say normally it would say the word obtuse or not, or it will tell me which one. So what I'm going to do is I'm going to pretend the angle I'm looking for, theta, I'm going to pretend that's a right angle. And the reason I'm going to do that is because if it's a right angle, then that means Pythagoras must hold. So in other words, if it's a right angle, 9 squared plus the side I worked out, which is 15.799 squared, square rooted, must be equal to 20 if it's a right angle. So let's do 9 squared plus 15.799 squared, all square rooted. That tells me it's 18.1 or 18.2. And because 18.2 is less than 20, if you think about it, I'm going to need this angle to be bigger to make my opposite side bigger. So therefore, and again, watch me go through that again just to make sure you understood that, because it's a really clever question, this. Whenever you do the sine rule, there are two answers and you have to make sure you've picked the right answer. So in this case, the correct answer is 104.1 degrees, because I know it must be bigger than 90 because Pythagoras didn't work. Good question, and quite a difficult question, very subtle, difficult question. Next question. All right, so having done a really difficult one, this is a pretty straightforward textbook question, isn't it? So I'm going to factorise out the 3. Now your teacher might do this slightly differently, but I take the 3 outside first and just leave the 16 on its own over there. Then I factorise inside the bracket, so that's going to be x minus 3 squared minus 9 plus 16. And then I expand the bracket, so that's going to give me 3x minus 3 all squared. 3 times minus 9 is minus 27, plus 16 is going to give me minus 11. And so my final answer is going to be 3 times x minus 3 all squared minus 11. Good question. Final question of the month, including this bonus episode, is calculate the area of the regular hexagon. And it's one of these whereby once you've seen it, you know what to do. And if you haven't seen it, you don't know what to do. So the quick way of doing this, if there are 6 equilateral triangles in a regular hexagon, then each side is 60, each angle is 60 degrees, which means the area of each triangle is going to be a half times by 9 times by 9. Well, how do I know that? Because I know it's an equilateral triangle that makes this up. Multiplied by sine of the angle in between, which is 60, and I want 6 of these to give me the hexagon. So that's going to be 6 over 2, which is 3, times by 81, times by root 3 over 2. Get my calculator again, and it's going to be 3 times 81 times root 3 over 2, gives me 210.444, and I'm actually just going to write equals 210 centimetres squared. Now, this is one of those things that if you've never seen it before, you probably won't know what to do. Remember, the hexagon's a really good thing in the GCSE because it's got parallel opposite sides. It breaks down to be an equilateral triangle or 6 equilateral triangles. There's lots of things about the hexagon that makes it a really good shape and a good thing to make sure you've done some practice with. So either way, go through that question again if you hadn't seen it before. Make sure you understand it. It could well appear in your exams soon. And that's it today. Really nice mix of questions to definitely end the month on, even if it is a leap year when you're watching this. As ever, do like, subscribe, let me know how you did, and I'll speak to you soon. Thanks all.